Okay, I'm going to go over y'all's study guide for your test on trig identities and the unit circle. First, we're going to look at some formulas that you'll need. You need your trig identities, and we're just going to try to write everything in terms of sine or cosine. And also you need to note if you have, like, you see tangent squared, that's the same thing as sine squared over cosine squared. Or secant squared is 1 over cosine squared, or cotangent squared is cosine squared over sine squared. So, and then you need the Pythagorean identity, sine squared plus cosine squared equals 1, which both of these are just the sine squared plus cosine squared equals 1, just rearranged. So if we took cosine squared and chunked it over to the other side, we'd get sine squared equals 1 minus cosine squared. Or if we chunk sine squared to the other side, we'd get 1 minus sine squared equals cosine squared. And you also need your unit circle. Make sure it's completed. Make sure you have all the degrees, the radians, and the coordinates on your unit circle. So like at 30 degrees, that's pi over 6 radians, and the coordinates root 3 over 2, comma 1/2. And you need your trig ratios from the unit circle. The unit circle, the radius is 1. And so sine would be your opposite over hypotenuse, or y over 1, which is the hypotenuse, which is y. So if it's asking for sine of 30 degrees, that's just the y part of the coordinate, so it would be 1/2. If it's asking for cosine, you're just given x, the x part of the coordinate. If it's tangent, you're going to divide y by x. If it's cosecant, you're doing 1 divided by y, secant 1 divided by x, and cotangent x divided by y. So these are the formulas that you'll need. So now let's look at your study guide, and we'll go over each question. All right, let's go over your study guide. Number 1 wants you to find tangent times cosecant. So I'm going to change both of those. I'm going to change or rewrite tangent as sine over, well, get the pen to work, sine over cosine times, and cosecant is 1 over sine and just multiplying these two fractions. If you see something that's diagonal, that's the same thing, and you're multiplying, you can just cancel them out. Diagonal or straight up and down, if you have the same thing, you can cancel them out. So this will give me 1 over cosine, and 1 over cosine is secant. All right, the next one, let's change cotangent. So I have sine theta times cotangent is cosine over sine. All right, so these two sine functions are diagonal to one another, so we can cancel them out. We're multiplying. So we're just left with cosine. Okay. Number 3, cosine squared over, and 1 minus cosine squared, that's your Pythagorean identity, is sine squared. Okay, so cosine squared divided by sine squared, that's going to be cotangent squared. Okay. All right, number 4, you have the square root of 1 minus cosine squared. That's the square root of sine squared, divided by the square root of 1 minus sine squared. That's the square root of cosine squared. All right, so if you take the square root of sine squared, that's just going to be sine, because sine times sine gives you sine squared. So the square root of sine squared is sine. The square root of cosine squared is cosine. And sine theta divided by cosine theta is tangent. Okay. Cotangent x, I'm going to change to cosine x over sine x, times secant x, I'm going to change to 1 over cosine x, where our cosines are diagonal, and we're multiplying so we can cancel them out. So we have 1 over sine x. 1 over sine x is cosecant. Okay, let's look at number 6. We have cotangent squared minus cosecant squared. That is sine squared. Get my pen to work. Sine squared over, nope, I'm sorry. It's cotangent is cosine squared over sine squared minus cosecant squared is 1 over sine squared. All right, this is subtracting two fractions. You have to have the same denominators when you subtract or add fractions, and here we do. We got the same denominator of sine squared, and so we're going to subtract our numerators and put it over our denominator. So we have cosine squared theta minus 1 over my denominator. All right, so cosine squared minus 1. Let's figure out what that is. It's not 1 minus cosine squared. We know that's sine squared. But cosine squared minus 1, what would that be? Well, if we look at our original Pythagorean identity, to get cosine squared minus 1, I would have to make my positive 1 negative and move it over here. And I would have to take this and move it over here. And so we would have cosine squared minus 1 equals, taking that sine squared to the other side would make it a negative. So we have cosine squared minus 1 is equal to negative sine squared. So this is negative sine squared over sine squared. And this is just going to give me negative 1. All right, let's look at number 7. It tells us tangent is 3/4. It tells us that degree, or theta, is between 0 and 90 degrees. That tells me what quadrant we're in. So we are in the first quadrant. So we got 0 degrees here, 90 degrees, 180, 270, and then back to 360. So if it tells me theta is between 0 and 90, and we know that we're in the first quadrant here somewhere. All right, so let's draw us a right triangle and theta. And it tells me that tangent of theta is 3/4. So remember SOHCAHTOA. SOHCAHTOA is opposite over, or tangent is opposite over adjacent. So if it says tangent is 3/4, your opposite is 3, your adjacent is 4. Okay, this is a triple, a 3, 4, 5. So now we can find sine theta. Sine theta is opposite over hypotenuse. Opposite's 3, hypotenuse is 5. All right. Sine theta on number 8 is 1/2. Cosine is √3/2. Secant theta. What is secant theta? Well, if you see that 1/2 and √3/2, that's your unit circle coordinates. Okay, and they're positive. They're both positive. So if they're both positive, that tells me it's in first quadrant again. But if you have cosine, then you have all you need for secant. If you have cosine, then we have all we need for secant, because secant is 1 over cosine, or just cosine flipped over. And so if we did secant theta, that is cosine flipped over, or 2 over root 3. And I need to simplify the 2 over root 3. Don't leave a root on the bottom. So we can rationalize the root by multiplying the bottom and the top by that root. So multiply straight across, we get 2 root 3 over root 3 times root 3 is 3.